All right. Well, I will get started here. Let me begin. Dear Heavenly Father, we thank you for this day. Again, I thank you for these students. Just ask that you'd guide our steps today. Just give the students courage to ask good questions as they have them, and just help us to make the most of this time we have, Lord, for your glory. In your name I pray, Lord Jesus. Amen. All right. So, any questions? The exciting Top Hat code is there. Please use it soon because I want to close that. Let me get straight into an example here. Let's see here. So let's try to solve the inequality x squared, I don't know, plus 5x minus 11 greater than 0. Now this one's uglier. It's uglier than the ones we looked at last time. You can't factor that, right? You can't factor it. So what do we have to do? We will complete the square. All right. So to complete the square here, we take half of 5, which is what? 5 halves, yeah. So we take x plus 5 over 2 squared. And then to be fair, I have to subtract the square of 5 halves, which is, by the way, 25 quarters, right? So minus 25 over 4 minus 11 greater than 0. So what I did right there was I completed the square. All right, now I want to make these add the fractions together, make a common denominator there. So how many fourths is 11? It's 44 elevenths, right? 44 elevenths is, 44 fourths is 11. So I have, what's 25 plus 44? All right, I'll use my calculator here. So what we'll do is we'll take 25 over 4 plus 11. That will give me 69 over 4. So I have minus 69 over 4. All right? Now I'm trying to factor it, but I realize that the factoring is going to be ugly this time. All right? So what I'm doing is I'm using completing the square to convert it to a difference of squares so I can factor it. Now, use your imagination a bit here. 69 is the square root. 69 over 4, I can trade for a square root of that squared, right? And then, so this factors like so. X plus 5 over 2 plus the square root of 69 over 2. X plus 5 over 2 minus the square root of 69 over 2 greater than 0. So what I've done right now, right here, these steps I just made, I refer to these as completing. This is factoring via completing the square. So we didn't do that too much in here. Maybe like the first example or two I did that. And then we were using the square root property to solve equations, right? But for this kind of thing, we really do want to factor because we want to take the expression we're given, right, and replace it with one where we can clearly see what the algebraic critical numbers are. What are the critical numbers now? So we either have minus 5, and then we have plus or minus the square root of 69, all divided by 2. Those are the critical numbers here. I can read that from these factors up here, right? And so take my number line. I'll make a number line for x squared plus 5x minus 11, all right? There are two critical numbers. Which one goes first? The minus 5 minus the square root of 69 over 2, or the minus 5 plus the square root of 69 over 2? Which comes first, the minus or the plus here? I guess it depends on, are you reading right to left or left to right, yeah? But if we read left to right, we got to put the minus first. We have minus 5 minus the square root of 69 rather, over 2. That's a negative number. In contrast, minus 5 plus the square root of 60. So the square root of 69 is about like 8.5-ish somewhere. I mean 8.4. It doesn't really matter exactly. The point is it's larger than minus 5, right? So this is a negative number. This is a positive number. All right. I'm using that roadmap we did last time. Remember the 4-step process? We're on step 2 at the moment. Step 3, we need to test some points, right? What number is between these critical numbers? This is negative, this is positive. In the middle, 0, right? Yeah, 0 is the easiest one. So 0 is up in here somewhere. And if we plug 0 into this, what happens? You get what? Negative 11, which is negative. Then I use my sign flip idea. So if I go across either of these, since we have just the power 1, we're going to flip signs, plus to minus or minus to plus. So like this and like that. So now I've completed step 3 in the roadmap. And from that, we can read the solution. What's the solution? Solution set equals minus infinity to this ugly number, minus 5 minus the square root of 69, all divided by 2, union with what? Minus 5 plus the square root of 69 over 2 to where? It just goes on and on and on, right? So to infinity. So that is the solution set here. Same idea that we did last time, but the difference here, the wrinkle, is that we had to complete the square because the numbers are ugly. The critical numbers here are a little bit more challenging, yeah? Any questions? Or should we do another? Let's do another of these, yeah? Example 2. Suppose we were going to try to solve x squared minus 6x, all right, plus 11 greater than 0. Now I don't believe we can factor. I'm pretty sure we can't factor this again, right? So I'm going to complete the square. We get x, what's half of 6? 3, right? So x minus 3 squared. Then I have to subtract the square of 3, which in this case is just 9. I add my 11. I'm trying to solve that greater than 0. So what do I have? I've got x minus 3 squared plus 2 greater than 0. What's the solution to this? We really don't need to write anything more. At this point, we can just use common sense, right? Like, look at the expression that you have. What x is this not true for? So look at this, right? Smallest this can be is what? Fill in the blank. You're adding x minus 3 squared to 2. What's the smallest x minus 3 squared could be? Could it be negative? We're not allowed to use complex numbers here, all right? That's not part of this discussion. We're just looking for real solutions to these problems. When you're dealing with inequality, you're looking for real solutions. The inequality doesn't quite make sense for complex numbers, as it turns out. So what is it? Smallest that could be is what? Plug in 3, right? If you plug in 3, that makes 3 minus 3, 0. Right? So if you think about it logically, the smallest that could be is 2. Right? It's 2. Anyway, my point is this is automatically satisfied, right? For any real number. So solution set is minus infinity to infinity. What if instead of having greater than in this problem, we had less than? How would that have turned out for us? Like the exact opposite, right? If we had less than there, the answer would have been nothing. Nothing worked. This is always positive, so there's no way to get x squared minus 6x plus 11 to be negative. You might think it could be negative. Like on first glance, it appears like maybe it could be negative, right? Because of that minus 6x, you think, oh, maybe that could win for certain numbers. But it doesn't, right? That's what completing the square shows. It shows that, in fact, this expression is, it's always at least 2. All right? Okay, anyway. Let us move on, unless there's a question. So next up is the study of absolute value. All right, so, oh, you already got it? Okay, cool. How do you define absolute value? What's the absolute value of x equal to? Well, here's a formula for it. You could say it's the square root of x squared. And what that works out to is minus x if x is less than or equal to 0, or x if x is greater than or equal to 0. It's a case-wise defined function. Now, if you doubt me about this formula, let me show you how it works for a simple example. Let's calculate the absolute value of, say, minus 5. That's the square root of minus 5 squared, right? Which is the square root of 25, which is 5, right? But what is 5? How does 5 relate to minus 5? Maybe you didn't think about this, but it is minus 5. Right? So that's how this case works out in practice for a specific number. All right? There's a trap students get into. You see something minus x and you think, oh, that's negative. But is minus x negative? That depends on x, right? If x is positive, it's negative. But if x is negative, minus x is actually positive. This is a common misconception people have looking at equations. You just assume that there's a minus, it means it's negative. Well, that depends on the context, you know? All right. What else can you tell me about absolute value? I'll just give you 2 basic facts here, and I'll derive one for you. So if we had like absolute value of x times y, that would be the square root of xy squared, right? Which is what? The square root of x squared y squared. Which then, by properties of algebra here, we could rewrite as square root of x squared, square root of y squared. All right? And hey, what's that? Well, that's absolute value of x, absolute value of y. So in other words, what do we find? That the absolute value of xy is the absolute value of x times the absolute value of y. So this is an important property of absolute value. The absolute value of a product is, in fact, the product of the absolute values. It's one of the things that makes real numbers so very special, is that they have this absolute value function. And complex numbers have something similar. Anyway, here's another thing. If we have absolute value of like minus x, right? We could rewrite that as what? The absolute value of minus 1 times x, right? Which is, by the property we just proved, the absolute value of minus 1 times the absolute value of x. What is the absolute value of minus 1? It's 1, right? So this is just equal to absolute value of x. So therefore, the absolute value of minus x is equal to the absolute value of x. So that's often a handy thing to know. Absolute value eats minuses. All right? Now, we probably won't even need these properties today. I'm just throwing them out to you just to remind you a little bit about how absolute value works. All right? But really, another way to look at the top equation, if you want to be a little bit less precise, you could summarize this by just saying what? It's equal to plus or minus x, right? Where you understand the plus and the minus go to the appropriate case, right? That's the principle that we're going to use to solve problems today, to start with at least. All right, so let's look at some examples with the absolute value equations. I'm going to show you two ways to do it. All right, so I'm going to start by using what's called the plus minus notation to solve the problem. Here's an example of that. So suppose we're going to solve the absolute value. Let's say 8 minus, 3x equals to 6. All right, there. So if I'm going to solve this with plus minus notation, here's how I do it. I go 8 minus 3x equals to plus or minus 6. Right? That's what we're up against here. Now I solve for x. So this would give me that 8 minus plus 6 is equal to 3x. So what I did was I subtracted or added 6 from both sides, which canceled out the plus or minus 6 on the right-hand side. And I added 3x to both sides. Do you want me to write it down? I could write it down. Here. Minus plus 6 plus 3x, yeah, and over here minus plus 6 plus 3x. So like the minus plus and the plus minus 6 cancels, and you get that. And though, okay, so then we divide by 3, and we get 8 minus or plus 6 divided by 3 equals to x. All right. And of course, if you wrote it plus minus, it really wouldn't matter. You could write that plus minus. You'd still get all the same cases in this context. So what does this give us? This either gives us the plus or the minus. What's the plus give me? X equals 2. 8 plus 6 over 3. The minus gives me x equals to 8 minus 6 over 3. So what are my solutions here? 8 plus 6 is what? 14, right? So I either get 14 thirds, or I get, looks like 2 thirds, right? 2 thirds. So there you go. Those are the solutions. In this case, there are 2 solutions. So this is the plus minus notation. Here's the other way to do these kind of problems. Is you can break it up into 2 cases. So suppose we were solving like absolute value of, 3x plus 2 equals to absolute value of, 11. All right, so in order to solve that equation, either you have 3x plus 2 equals to 11, or you could have 3x plus 2 equal to minus 11. So I just write them separate. 2 separate problems. All right? And these are linear equations, so it's not a lot of work to write down both problems separately, is it? Not really. So if you're more comfortable with the way I'm doing example 4 as opposed to example 3, well, feel free. You'll have time. So we have 3x equals to 9, right? We subtract 2 from both sides. And then divide by 3, we get x equal to what? Three, right? X equals to 3 on this side. On the other side, what happens? We get subtract 2 from both sides, right? So we get 3x equals to minus 11 minus 2, which is what? Minus 13. And then what? Divide by 3. which gives us x equals 2 minus 13 over 3. If you want, I can rework example 4 using plus minus notation. You want to see it?
Are we going to have to know plus minus notation for the test?
Not necessarily. Sure, why not? So we have 3x plus 2 equals 2, absolute value 3x plus 2 equals 11. This gives us 3x plus 2 equals to plus or minus 11, which gives us 3x is equal to plus or minus 11 minus 2, which gives us x is equal to plus or minus 11 minus 2 divided by 3, which gives us x is equal to 11 minus 2 over 3, or minus 11 minus 2 over 3, which is to say x is equal to 3, or x is equal to minus 13 over 3. It is marginally faster, but honestly, like 30 seconds versus 45 seconds, like whatever, you know. Whatever you're more comfortable with, do that, okay? The important thing here is this. If you're solving an absolute value problem, right? If it has a solution, all right, we're talking about an equation, odds are you probably are supposed to have 2 solutions, right? Now there are some problems that have no solutions, like this one. Try this on for size. Example 6. Absolute value of 3x minus 1 plus 2 equal to 0. Solve that. Can you solve it? Well, look at it. What happens here? This gives us that the absolute value of 3x minus 1 equals to minus 2. Uh-oh. This is a problem because I have buried the lead, incidentally. One of the properties of absolute value I really should have emphasized to you, and this is maybe the most important property of it. Hey, but don't feel bad. The last section didn't even get to hear this, but absolute value of x is greater than or equal to 0. This is a crucial property of absolute value. It is non-negative. It can be 0, but it cannot be negative. So when you look at this right here, right? Absolute value of 3x minus 1 equal to minus 2. You know, to quote my community college professor, this dog will not hunt. You know, I mean, you can't do this. He's no allowed. All right, so no solution. In other words, solution set is the empty set in this case. All right. Okay, so it may have been a few years since you've solved these, right? But you probably solved these in your high school algebra course, right? You feel, I mean, it's rusty, but you maybe remember a little bit. That's kind of it. There are other flavor options here, and we'll see if we can get to those on, you know, Friday probably. But what I'm going to turn our attention to now is absolute value and inequalities, because that requires a little bit more finesse. So I think the healthy thing to do with absolute value inequalities is to just stop and appreciate what does absolute value mean geometrically. All right, so let's just discuss it. So it's the geometry of absolute value. All right, so let B be a positive number, okay? If we look at the absolute value of A being less than B, all right? What does that mean? What is the absolute value of A? Well, the absolute value of A, I guess I should, maybe I should throw up a numerical example just on the board right quick so we're on the same page. Look at this. If I look at, say, minus 3 and 3, right? Zero's in the middle, right? What's the absolute value of minus 3? What's the absolute value of 3? What do those both represent geometrically? Distance from 0, very good. So that's really what the absolute value is about. It's about the distance from 0. Right, so it's giving us the distance to the point on the number line, distance from 0. So when I look at the absolute value of a is less than b, this means the distance of a to 0 is less than b units, right? So if we draw a picture of that, what's it look like? We've got minus b over here, we've got b over here, right? 0's in the middle. Where is a? Somewhere in there, right? Somewhere in here, right? So what does that say about a? If we want to write it in terms of just inequalities, not of absolute value, but just numbers, think about this. This means that minus b is less than a is less than b. All right? So this compound inequality is equivalent to the absolute value of a being less than b. So this right here is a critical observation for solving problems. This definitely is something you want on your formula sheet. Now you could rewrite it. You could put this on the left-hand side and that on the right-hand side. I mean, whatever logically is most useful. In the last section, I put this on the left-hand side and I put that on the right-hand side. Whatever. How does this story change if instead of having less than, we have greater than? Think about this. If we have the absolute value of a is greater than b, that means the distance from 0 to a is more than b. What does that look like on the number line? Right? We've got minus b here, we've got b over here, 0's in the middle. There are two cases, right? Either you're to the right of b, or you're to the left of minus b in this context, right? So a could be over here, but a could be over here. A can't be in both places, though, right? Here, a is subject to both of these inequalities. A is both less than b, and it's greater than minus b. Over here, it's not the case. Either we have a, which is less than minus b, or disjoint case, a is greater than b. There's a large asymmetry between these problems. And so what I'm describing to you is that our thought bubble over here is absolute value of a is greater than b if and only if a is less than minus b, or a is greater than b. All right. Versus absolute value of a is less than b if and only if minus b is less than a is less than b. So these are, see the difference? Very different. So this is our backdrop, all right? We're going to hang all of the examples past this point on these two observations, all right? So like, here's an example. Where am I? Example 7. Suppose I have absolute value of 3x minus 8 is less than, 4. We want to solve this inequality. So basically what I want you to think about is, think of this as being a, right? And think of this as being the b in this pattern, yeah? So I can take this and rewrite it as minus 4 less than 3x minus 8 less than 4. Hey, now we're back to where we were earlier this week, right? What do we want to do? We want to isolate the x, right? So I think what I'm going to do, I'm going to add 8 across this inequality, yeah? Plus 8, plus 8, plus 8. So what we got? We got 4 is less than 3x is less than 12. Now what? I heard a divide. Divide by what? Divide by 3. So we've got 4/3 less than x. Less than 12 over 3 is 4, right? At this point, the solution set becomes apparent, right? What's the solution set? Looks like we've got 4/3 all the way over to 4. There you go. The solution is that. What happens if instead of saying less than 4, I put greater than or equal to 4 for this problem? So let's do the same pattern, but instead of less than, let's do greater than or equal to. What happens? See, now I have to break it up into 2 cases. I have to face that there are 2 cases, 2 disjoint cases here, separate cases. I either have 3x minus 8 is less than or equal to minus 4, or I have 3x minus 8 is greater than or equal to 4. These are not the same x. Again, these are disjoint cases. Okay, so then what? Again, now we've got 2 inequalities we've got to solve, you know? So I add 8 to both sides here. And that gives me 3x less than or equal to 4. So I get x is less than or equal to 4/3 from that one. I'll do the other one in purple. Add 8 to both sides, yeah? So we get 3x is greater than or equal to 12, right? Now I will divide by 3. We get what? X is greater than or equal to 4. All right, what does this mean about intervals? X is an element of what interval for the red? See, this means that x is an element of minus infinity to 4/3 included. That one means that x is, so we could also write this as 4 less than or equal to x, right? So would that be like a union? Yeah, you are correct. Give me a second here, we'll get to it. I mean, you're absolutely right, we're getting there. I'm working my way there. No, you're fine, it's fine. What'd I do? See, I always make these comments after the person leaves. It's no fun, they need to hear the comment. The comment is intended for the person who left, not the people who remain. I was telling the other classes when somebody left class early, like, you know, if you've got another class like across campus and you need, for whatever reason, like the 15 minutes between classes is not enough to get to Green Hall, and the person over there is like pretty much a stickler for like getting there on time and they take tardies and all that kind of stuff. You need to leave here 10 minutes early or something. It's fine. I just would expect you to watch the video later, you know. So, I mean, hopefully you don't have to do that, but if you did, you had a presentation or something, I'd understand. Just let me know. Anyway, so yes, union is the way to go here. These are, you know, this funny looking E, some of you are wondering what that is. You're not asking me for reasons I don't understand entirely. Maybe it's just because I'm so mean and scary, but that is element of. I'm just kidding, I'm not scary. Let's see here. So, but you can ask my children, I'm very mean. Okay, it's not really true. My wife sets a high bar. Missouri. I mean, I'm scared of my wife sometimes, but let's see here. Depending on, what I've done. Let's see here. So minus infinity, 4/3 union, and you're like, he's married? Yes, there's hope for you too. Let's see here. So it definitely wasn't a work of my own. It's the grace of God. I'm married, nothing else. So minus infinity to 4/3 union, 4 to infinity is the solution set here. There is a relation between these two problems. Do you understand it? What is the relation between these two problems? Let me draw it on a number line, yeah? So if we look at this, right? 4/3 to 4 maybe is like this. All right? So this was the answer to example 7. Example 8, where is it? See it? It's everything else. It's either over here or it's over there. If you put these two together, you have everything. Right? In that sense, they're complementary. I often ask a question on the quiz or test like this. If you're reading the test or the quiz and you feel like you have this strong sense of deja vu, like it's the same problem repeated, odds are, if you look at it more carefully, one of them has less than, the other one has greater than or equal to, or perhaps just greater than. If you understand the relation between these two problems, you can check one problem with the other, because their answers should be sort of like whatever's not the answer for 7 has to be the answer for 8, and vice versa. Whatever's not in the answer for 8 must be the answer for 7. So incidentally, I was just talking to another faculty. He used to teach, here's how he used to teach it. Not how I'm going to teach it, but it is an interesting strategy. He's like, to solve these problems, what he teaches the students to do is to instead solve that problem and then take everything that's not in there as your answer. So I'm not going to advocate for that, because I feel like what's going to happen if I try that is you're just going to like forget the last part of it and just always give me the answer to 7 for everything, which is what tends to happen for students anyway. But hey, let me not say that. Let me not poison the well here. You guys are going to get these right. Everyone's going to get these problems exactly correct on the quiz. There will be no weeping and gnashing of teeth. Everyone's going to get these problems correctly. Right? Right. Usually the standard, the most popular mistake for these problems is to forget about the minus. People just say, oh, absolute value, I don't like that, let me just ignore it. And then they just go 3x minus 2 plus 2 equals 0, solve that and give me one answer. I mean, that'll get you half credit, but you'd like all the credit, right? All the credit. I don't want your points. I have enough points already, you know? So, Any questions? All right. Let me see if I can come up with another example for you guys. How about if we want to solve absolute value of, let's say, 12 minus 5x less than, how about 2? How would we solve this? You're like, oh, thankfully, a less than problem. Yes, the less than problems are easier because all we do is we trade this for the compound inequality minus 2 less than 12 minus 5x less than 2. All right? Again, I'm using these back here. I'm using the things we talked about at the start based on the geometry here. I want to isolate the x, right? So how about we, I think we need to subtract 12 across the inequality, yeah? So minus 12 which leads us to minus 14 less than minus 5x less than minus 10. All right. Now we got to be careful, right? Because we got that pesky minus 5. We want to get x, right? So we want to divide by minus 5, right? So divide by minus 5, what happens when we do that? Yeah, it flips the inequalities, right? So we get minus 14 over minus 5 greater than minus 5x over minus 5 greater than minus 10 over minus 5. Let me clean that up a bit. So what we're looking at is 14 fifths greater than x greater than 2. It's hideous. Don't look at it, you know. Let's turn it around. So do you guys know that Volkswagen Jamaican commercial? You know what I'm talking about? Everybody seen the Jamaican Volkswagen commercial? It was somewhat politically incorrect, apparently. I don't know, there was debate. But in this, there's this guy from Minnesota with like a heavy Jamaican accent. It's just, I don't know, it's just funny to me. And one of the things he says is, you know, turn that frown the other way. So that's what we're doing right here. I guess I'll have to show you the commercial. Anyway, so now we can write down the answer. The answer is, survey says, solution set equal 2 to 14 over 5. All right, guys, so why don't you try it out for yourself. Can you solve 12 minus 5x greater than or equal to 2? Solve that. Everybody top-hatted? I got 31 of you. How many are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so everybody who's here is here. Cool. All right, so what do we, how do we start? You're like, I was paying attention, so I can just write down the answer from the previous problem. I mean, that is true. You know, you should be able to anticipate that the solution here would actually just be what? Minus infinity to 2 included, unioned with 14 over 5 to infinity. I can tell that directly from looking at the last problem. But let's work it out, yeah? Okay, so I'm going to add 5x and add 2 to be just to do something different. That gives me 14 less than or equal to 5x, which gives me 14 over 5 less than or equal to x. Okay. And then over here, I will subtract 2 and add 5x to both sides. In so doing, I will get 10 greater than or equal to 5x. Divide by 5, I get 2 greater than or equal to x. So this gives me solution of x is bigger than 14 over 5 or equal to it. So I get 14 fifths to infinity. And over here, I get minus infinity all the way to 2. All right. So therefore solution is 14 over 5 infinity unioned with minus infinity to 2. Now, like I said, you can anticipate that from just looking at this and thinking about what's not in this open interval, right? It's everything, you know, to the left of 2 and everything to the right of 14 over 5, which is what we found over there. Yep.
So if you switch like x to the other side, like you added that,
Yep.
then you flip this side.
Oh, no. Okay, so when we add or subtract things, we don't have to flip the inequalities. It's when we multiply or divide. That's what flips the inequalities. Now, let's look at that for a second here. Another way you could have done this, right, would have been to subtract 12 from both sides. We would have gotten minus 5x is less than or equal to minus 14, right? That may be how you did it. And then we divide by minus 5, right? So then x is greater than or equal to minus 14 over minus 5 if we did that root. Then if the dividing by minus 5 flips it. And of course, all paths are going to lead us to the same, you know, truth here, which is that x is greater than or equal to 14 over 5. Of course, I've written it in the opposite way here, but it's the same thing. But yeah, sometimes when I just don't want to, sometimes if I don't want to have to multiply by the negative number, I just add the variable to the other side to avoid that step. I don't know. It's like a lot of different ways to kill a cat, right? Anyway, we win. Oh, I'm sorry, dog. Is that better? Okay. No? Sure, why not? Hopefully you won't be deafened. We'll find out soon. Well, second here. Oh. Hey, come on. Oh man, come on.
So in conclusion, I think this one. You know what this room means? A smile. Who wanna come around? Traveling along, there's a song that we're singing. Come on, get happy.
You guys are 3 minutes late.
Don't be no cloud on a sunny day.
Yeah, chill, Winston.
Sir?
Respect, boss man.
That's the power of German engineering.
It gives me joy. If I could commit to a Jamaican accent with a proper misuse of pronouns for a whole semester, it would be amazing.